everyone, to another edition of the Binding Status. This is the seventh episode. We've been away for a little bit as we've been at KubeCon and just getting out some releases of Crossplane as we've moved to a monthly cadence. But I'm really glad to be back on here. This show may be a little different than previous ones because we are celebrating the 1 year anniversary of Crossplane. And so today we're going to talk about a little bit of the history of the project, so pretty much everything that's happened over the last year, as well as look forward into what we're going to be doing, where we're at right now, and how we're going to get to that future state that we desire. And obviously some of that will be speculative, but it will be nice to kind of get a feel for the roadmap, so that if you're a user, you're interested in contributing or something like that, you can go ahead and get involved and kind of know where we're going. Before we get started with that, I put this out on Twitter when I announced that this show would be happening today. I followed up with a tweet about how this 1 year kind of anniversary of the creation of Crossplane, or the open sourcing of Crossplane, is super important to me. And I wanted to touch on that briefly. I know that not everyone tunes in just to hear me talk about my personal feelings towards the project, but I think that it's pertinent to anyone who's interested in getting involved. So on December 4th of 2018, when Crossplane was announced, I saw that announcement, and I was actually a senior in college at that time, and I thought this was a really great project and had a really great mission. I had kind of gotten interested in infrastructure software throughout college, and hearing about this ability to make a standardized control plane across cloud providers, which was clearly the direction that software was going in the enterprise, was really appealing to me. And so I wanted to get involved. And this is the part that I think is really important for anyone who's interested in joining our community, is from day one, and mind you, this was a pretty small project right off the bat, not a ton of people contributing at that point, and it's certainly grown over the last year. But I was just really welcomed in, and people taking individual time to talk to me and get me onboarded, to the extent that it was helping me more than it would give back to the project. Now that I've become much more involved in the project, I think that it probably has paid off somewhat. But at that point, it was definitely people willing to spend time with me and help me learn, just for my own personal benefit. So really caring about people in the community. And as our community has scaled, I think that has continued to happen. And as I've kind of grown into more of a larger role in the community, I really am passionate about keeping that going, and I know that a lot of the other people are as well. So if you're watching this, if you are a college student, or you have been working in software for 30 years, if you're interested in being part of this community, we want you here, and we're happy to have you, and we're willing to take as much time as needed to get you to a place where you feel like you can contribute or start using Crossplane, because the project is really nothing without users and contributors. So I just wanted to put that out there. I thought that was appropriate to talk about at this 1 year birthday mark of Crossplane. I'll now get into talking about a little more pertinent things to the project, but if you are interested, please feel free to reach out to me directly, or anyone else in the community. Join our Slack, and we usually chat about things there. So let me hop over to our traditional streaming setup here. So what I have up here is the blog post that was written by our very own Jared Watts. It's also linked in the description of this video. And I'm just noticing Marcus saying to bump up the volume of my mic a little bit. In OBS, I have it all the way up, so if it's gotten any better, let me know. Otherwise, I'll see if I can do anything else, or I can just talk really loudly. I usually don't have a problem with that. But anyway, so we have this blog post that kind of gives a brief overview of this first year of existence of Crossplane. It's really insightful to hear this from Jared, because he is one of the founders of the project, and also one of the founders of the Rook project, as he notes here. And let me check on this mic again real quick. I'm getting some messages about it. Oh, okay, here we go. It looks like we are good to go on the mic volume now. So Anyway, Jared is one of the founders of the project, so he has kind of the full life cycle picture of what the purpose of Crossplane is and how it's grown over time. So I would really highly suggest you checking out this blog post. It's pretty short and also kind of will give you some ways to get started with Crossplane and learn about how it's evolved. Also, another thing to look at, and I'll add this to the repo when we update the notes, is this Introducing Crossplane blog post, which is from December 4th of 2018, and talks about the original vision for the project. It also links to the architecture document in here, which goes into a little more detail. This is actually now pretty out of date in terms of the actual architecture of the project, which we can get into a little bit later, but it is useful to understand the initial mission, and so that's useful to check out. And that's one of the things I've really appreciated about the project and the community over time, is that I feel like we've stuck true to this original mission that was put forth, while also taking in user feedback and incrementally improving things and listening without deviating from our normal path. So that's been really cool. I like to use the analogy of a long time ago when I played football, I had this coach that would coach the linebackers and say, our goal does not change. Our goal is to tackle the ball carrier, but we don't know where the ball carrier is going. It's a moving target. So I think creating this open multi-cloud control plane is also a moving target. So our goal doesn't change, but we have to take a different path to get there depending on how the target moves. So the way you do that is you take small incremental steps. You're always moving forward, but you never take too big of a leap that you get to a place where you're going to have to undo a lot of progress or work that's been made. You slowly, daily move towards that goal, and that way you don't kind of get out of sync with what your mission is, and you can also quickly change directions because you're not moving super quickly. Or you are moving quickly. You're not moving great steps at one time, though. All right, so the main purpose of this show today is to talk about kind of where we were and where we're going, and I think examining some of these decisions that we've made will help us frame for how we're going to move forward in the future. So starting out, we had this idea of static and dynamic provisioning and workload portability. That's kind of the main thing that happened. So I'm going to try something a little new here, drawing diagrams. I think that this will be useful. It may also just be really boring to watch, so please feel free to give me that feedback. But I want to kind of show how the architecture worked before and how it works now. So we've always had this claim class model of Crossplane. So let's say a claim is kind of a generic representation of a resource that may be available on multiple cloud providers. So that would be something like a MySQL instance. So this is a representation of a claim that can be used to create an object on or an infrastructure resource on multiple cloud providers. AWS has RDS instances, Google has Cloud SQL instances, and Azure and others have their own representations as well, all which can speak the MySQL protocol. Then the other thing that we have, here, let's make this the same size actually. The other thing that we have are classes. So starting off, we just had one type of class, and it was called a resource class. And this was kind of unstructured schema for how you could create resources. So it may have specific things like size of a database, or it could have number of nodes in a cluster, anything like that. It was a single custom resource that could be used to provide configuration for any sort of managed resource, and could be claimed using any sort of claim type. So if we look over here in the original architecture here, you'll see this generic resource class type. And another thing that's important to notice is at this time, originally, both the claim and the class, as well as the managed resource that's created, which we'll get to momentarily, were namespaced. And that's pretty common for Kubernetes. Marcus comments, this video for more open source is like football analogies. Yes, so I may be a little unorthodox in my explanations sometimes, but I appreciate y'all sticking with me. But back to what we were talking about, these were both namespace. So as you can see, there's kind of these parameters here, which may be for a MySQL database, and it has this provisioner type, which specifies what type is going to satisfy it. Or it may be for something like a Kubernetes cluster, but there's just one custom resource type that can be used to do that. So essentially, what you would do for dynamic provisioning is you would take this MySQL instance, you would point it at a resource class, and this would lead to the creation of what we call is a managed resource. So let's say, in this case, our managed resource is something like an RDS instance. So together, this MySQL instance and this resource class can be used to create a RDS instance. So this is the original model. Keep in mind that all of these are namespaced objects. And the creation of this actual managed resource is watched by a controller, meaning that I'll say this is kind of the barrier. So all of this is in a Crossplane cluster. And they provision something like an actual RDS instance on AWS. So the main goal is to provision these resources on the cloud provider eventually. So this is the initial model. All of these are namespaced. There's not really strongly typing of the resource classes, so the configuration may or may not provide what's necessary. There's also this surfacing of details to the claim. So if we go back up, you'll see that there is these different fields on the claim that can be used to also configure the resource to kind of customize the class configuration at deployment time. So as we move through time, this model has evolved quite a bit. So let's see. I will create kind of a barrier here. So this is the previous model. And let's just fill this here. And this has evolved to, at this point, look more like this. So we still have this same claim that exists, but now instead of a single resource class, and Marcus points out that also this provisioning of the RDS instance creates a secret. I'm going to omit that for now and come back to that just because it adds a little bit of complexity to the model. But I'll continue going with this and circle back to some of those points as well. So instead of this single resource class now, we have strongly typed classes. So we'd have an RDS instance class. And this can be claimed by a MySQL instance. And we have a similar model here. In that it does the same provisioning as you'll kind of see on the left-hand side of this diagram. But now we know for certain that the fields required are on this RDS instance class. And essentially what happens is there's a controller watching the creation of a MySQL instance claim, and it uses the configuration from the RDS instance class and basically just copies that over to the managed resource RDS instance, which again leads to this same creation of an RDS instance on AWS. Some other changes here are that before, these were all namespaced objects in Crossplane, but now only the claim is namespaced. So the RDS instance class and any strongly typed class as well as the manage resource that's created, are cluster scoped. And if you think about this from an organizational perspective, this makes sense, right? Because if you think of a namespace as an application environment, so let's say I'm on an application team and we want to deploy a new app that we've created. Let's just say it's a blog and it needs a MySQL database backing it for posts and comments and that sort of thing. Let's say there's multiple teams that need to use MySQL instances. We're creating the blog, but there's others in other namespaces that also want to create MySQL instances to back their applications. We may all want to use this same configuration. So being at the cluster scope allows us, all of us, to reference that from our claim. And then the RDS instance should also be cluster scoped, because it kind of exists in this infrastructure realm, right? It represents something outside of the cluster that is being used by an application in a namespace. So I'm now noticing that virtually could have copied this all over here, but I'm going to annotate these because I think this is useful for actually seeing the model. So this is namespace scoped. This is cluster scoped. This is cluster scoped. And then this would be what we refer to as external. So once again over here, just to make it abundantly clear, and if we want to use this diagram later on, this is going to be namespace, and namespace. So I think this is a good example here of changing our model of provisioning while also sticking to our main goal, which does not really change with this, but it's enabled, the implementation enables a more useful organizational structure for provisioning resources. Another thing that, as Marcus pointed out in the chat, is that the provisioning of this resource also propagates a secret, right? Because you need to be able to connect to this external database so that you consume it from your application. So this is something that has been part of the design from the beginning. If we look down here, getting to workloads, I believe it's actually in this blog post from the initial announcement, is this kind of injection of secrets into the application. So we'll get to workloads shortly, which are now a little bit different as well. But essentially what you want to be able to do is, in your application namespace, so where this MySQL instance exists, you want to be able to consume this RDS instance. So what actually happens here is a connection secret is created for the RDS instance. So let's see, what would be a good shape? We'll use a hexagon for the connection secret. And let me fill this in with another color here. This is fine. So let's say RDS connection. So this is of type secret, which is a Kubernetes native concept. So this is how you are connecting to the cluster. And when a cluster is claimed, it actually, you want to take this connection secret and put it in the namespace of the claim. So this is a side effect creation here. And when this resource is claimed, then we also want this secret present up in this namespace. Let's see here. All right, so this is kind of the model we're at right now. So making this even more concrete, we can add in, let's see, let's add in something that kind of helps us denote namespaces and cluster scoped things. So let me make this transparent here. And as mentioned at the beginning, please feel free to jump in with any comments or questions as I'm going through this. So we'll treat these boxes as a namespace. So this would be one namespace in this model. Also, the connection secret that is sort of the infrastructure connection secret is written to a namespace as well. So once again, going back to that idea of that this is an application namespace, and then the cluster is kind of where all the infrastructure lives, or any infrastructure configuration lives. So when we think about this from a workload consumption model, as I mentioned before, we had this concept of a workload in the initial design that's now represented as a Kubernetes application, which is a type of workload. We envision in the future we'll have additional types of workloads, but essentially it does the same thing right now, where it's going to be a namespace scoped object. So you could create your Kubernetes application here. We'll reuse something like this. So you could create that in the namespace of your application. And now that this secret is present here, then you can inject it into any containers that you may have running as part of this Kubernetes application. I'm struggling with the arrows a little bit here. Sorry about that. So that allows you to basically use this managed service alongside your Kubernetes application. So this is kind of an example of how the ecosystem has evolved. Once again, this was all possible earlier on, but it was all encompassed in a single namespace. So if we look at this model, then we see this all as a single namespace, which drastically reduces the portability across different application teams and that sort of thing. So now that we have this, and you could once again, these secrets exist also in the original model as well. So let me send this to back, and to back. So previously, you'd also have, that's not what we want to do. You'd also have this secret in the namespace, which could be consumed by a workload at this point. So it could also point to the secret, and it could still be utilized, but it just wasn't as clean of a model for it, essentially. So this is all namespace. It's really isolation of resources to a single application. So once again, the same thing is possible with Crossplane, but it's now more conducive to an organizational structure where you have platform teams, you have application teams, you have infrastructure teams, and all of this becomes possible. One thing I want to touch on momentarily is how we want to actually provision and schedule Kubernetes applications, so workloads to different Kubernetes clusters, because it's pertinent to where we're going. But I think this is some of the main updates for where we have come from here. Another thing that has happened kind of at a wider scope than this is the breaking out of different stacks. So if we looked back, and we can probably jump back pretty quickly, let's take a look at one of the earlier releases of Crossplane here. And what you'll see in here is that we have things like AWS, Azure, and GCP here within the actual Crossplane project. So this is the initial release that came along with that blog post. Now, if you look, we have things like Stack GCP, Stack AWS, and Stack Azure. And we only have these namespace claims that we mentioned are portable across different cloud providers and different stacks living in core Crossplane. And what that does is allows anyone to come along and basically provision their own stacks. So a big thing that I'm really proud of is the adoption of some newer stacks here. So you'll see things like Stack Packet. So Packet delivers basically bare metal infrastructure, and they've built their own stack to be able to provision resources in Crossplane. And then also CloudScale has done a lot of work, and they actually have some great blog posts about this as well, to be able to provision their resources as part of Crossplane as well. So now you have this two-step process of installing Crossplane into a cluster, which brings along things that are portable across, so things like the claims, things like Kubernetes applications. Those are all installed with the core Crossplane as well as the Stack Manager. And the purpose of the Stack Manager is to basically bring along these cluster scoped resources, like an RDS instance for AWS or something like a Cloud SQL instance, or even other Kubernetes cluster offerings like GKE or EKS or AKS, something like that. Any alphabet soup you want to put together to be able to create a managed Kubernetes service. So I'm going to zoom out a little bit here. We have this changing of the model here, and we also have the way that these resources are brought changing with the extensibility of stacks. So I think that's the main points of where we're at right now. Another thing that is important is cross-resource references. So it's really easy to look at these resources as something that kind of exists in a vacuum, but if you've ever used a cloud provider, you know that it can be really difficult when you use multiple different resources to connect those together with various networking resources. So something that you'll see on the Crossplane website and our documentation are different walkthroughs about how to deploy kind of like fully managed solutions. And you'll see things like global addresses and connections. It's even more complicated in something like AWS, where you're creating subnet groups, security groups, and that sort of thing. Let's see if the Stacks guide has a walkthrough of creating an actual network. Yeah, so here you see we actually create a VPC and subnets and that sort of thing. And if you're just consuming an RDS instance by itself, a lot of this isn't really necessary. But if you also have something like a Kubernetes cluster that needs to connect to these this RDS instance without, opening it up to the public internet, then this gets a little more complicated. So something that was added as part of our most recent release was this continuous deployment, and that is accomplished via cross-resource references. So let's see if we have any PRs here. Yeah, cross-resource references. So Javad, who I think is on this call, I think he mentioned that he was there, basically created the ability to reference between different resources. So to create a subnet, you need to reference the name of the VPC. Well, if you don't want to wait for that VPC to come available and then check the name and then manually create the subnet, then you need to be able to reference that resource. So with something like an RDS instance class, what you could do, if you wanted it to have a reference to a subnet, let's say, and this may not be a super realistic example, but you could create a subnet object So this is a managed resource, which is why I've kept it the same color. And then you could reference that. So let's see if we can pick a different kind of connector for referencing. And let me change the style here of this line. Let's see. We'll do this type of, oh, that didn't work. We'll do a dashed line. So you have this reference here to the subnet in the class. So imagine that this doesn't exist yet. This claim hasn't referenced a class and hasn't created the RDS instance. Then when you created this claim and there's this reference to a subnet that exists in Crossplane, then you could essentially populate that subnet field in the RDS instance class and use that to provision the RDS instance manage resource, which then creates the external resource. So the value of that is that you can now provision all these things at one time. And if you look into our docs here, you'll see things like a TLDR section that basically just says, apply this entire directory here. And what it's going to do is it's going to create a subnet. It's going to create a class that references this subnet object. So at the class creation time, it doesn't know what the subnet value is. It's just saying use this subnet when we provision it. And then when we claim this to actually create the managed resource, it's going to say, is this subnet resource available for use? And if it is, let me take the name and actually make the API call to AWS to provision this RDS instance with a reference to that subnet. So that's why you get kind of two-step sort of processes here. So you can see the value of that is that scales when you create something like a full VPC with numerous resources in it that kind of all have inner resource references. And when those resources get provisioned, then you're able to create resources that are all interconnected together. So let's say that you want to also have a Kubernetes cluster that this application is scheduled to. Then you may have something like a Kubernetes, or excuse me, on AWS, we're going to have an EKS cluster class, which also references this subnet. And in our application namespace, it's not what we want. In our application namespace, we are going to have a Kubernetes cluster claim. And this Kubernetes cluster claim is just like the RDS instance does. And we are starting to get a little unruly with our diagram here, but we will press on nonetheless. It will reference this EKS cluster class, which will in turn create, and let's see if we can move this here actually. Make this a little bit cleaner looking. I really need to get better at making sure my arrows are connected here. All right, let's move this to here. We should also note that this subnet leads to the creation of subnet on AWS, which is external. And when this EKS cluster class is created, then we are also going to create an EKS cluster which is cluster scoped. And will lead to the provisioning of EKS, sorry about that, EKS cluster on AWS, which is once again an external resource. But the difference is here, and you know, there's actually a lot more resources that will probably have to be created for connectivity, but we're just assuming that you can create an RDS instance and an EKS cluster in a subnet, and then they can automatically talk to each other here. So don't actually play this example out in real life. It's probably not going to work for you. If you want to do this, then I would recommend following the guide here that Javad did some awesome work on. But let's say if they both are, you know, have a reference to the same subnet that they're able to talk to each other. Well, now that these have been provisioned with this reference, we have a Kubernetes cluster and a MySQL instance that can talk to each other. So if this Kubernetes application, which once again is just a bundling of a schedulable workload of Kubernetes resources onto a cluster. So we're going to, and we can also talk about this momentarily, is schedule this Kubernetes application to this cluster. So once again, this is present day how it works. And that will mean that the Kubernetes application is deployed on this cluster. So it will be deployed here, which is in this subnet. And this RDS instance is here, which is also in the subnet, which means this application, which has the connection information to talk to a MySQL instance, is running in the same subnet with that MySQL instance that it can communicate with. So if we visualize this sort of on the AWS side of things, which looks like we have a rogue arrow down here, then we can end up with this kind of model, which will be a lot more familiar to people who are familiar with Kubernetes. So let's make this something like this. All right, font color, it looks like it automatically updated. So here we have, well, let's look at an example that we provision here. I believe this is going to use WordPress. Oh, this is a stacks guide, so it's not going to show the full thing. We'll jump over here and see if the Kubernetes application, well, actually, we can just show the literal YAML here. All right, so here you'll see the actual Kubernetes application. This might make it a little more real for everyone. But you'll see in here, it's just a collection of resources. So these resource templates. So we're creating a namespace, we're creating a deployment in that namespace, and we're creating a service. You'll also see that we're injecting from the secret here, this information about how to connect to it. And we're referencing this SQL this secret by name, which is the connection secret that we have here. So what you'll end up with in this target cluster is a namespace, a deployment, and a service. And the service is going to allow it to be exposed to the public internet, and the deployment is using this secret, which is here, which is propagated all the way to this target cluster. So you'll actually also have a secret here that the deployment is consuming. So you'll have something like an endpoint and maybe password information and that sort of thing that allows the deployment in this EKS cluster to talk to this RDS instance, and we've set it up such that they can communicate with each other. Once again, just a subnet is not enough to do that in this case, but it is a nice example of what that could look like. So, with a view of how we currently look, And once again, this is all in a single Kubernetes cluster, your Crossplane cluster. And then this would be a remote cluster. Let's look at some things that we have envisioned for the future. And I'm also going to look over at the comments here. Looks like Javad is here. That's a great way to put it. Awesome. Thanks for that affirmation, Javad, and thanks for the work you've done on this. Yes, Marcus says the right side of this diagram is about to need many more AWS resources. It might have actually been more useful to use something like GCP, which requires less. But once again, we're just saying this subnet here. What you'd actually need is, a VPC and a subnet and firewall rules and that sort of thing, which are all supported here in Crossplane as well. Here you'll see a DB subnet group and that sort of thing, which this would be where you have a reference to something like the actual subnets. So with some things that are open right now and some main areas that we want to improve upon and we've heard feedback on are how we can do all of this that I've shown in a much simpler manner, right? This is a lot of stuff going on. It's a powerful model which allows for countless different scenarios of provisioning resources, but it can get complicated, especially if you don't know how you want to configure these classes, which can get somewhat unwieldy when you're trying to make them able to be connected to each other. So one of the big ways we've done that is by discussing this kind of easy stacks idea. So an easy stack is basically a way that you can define repeatable deployments of infrastructure without writing any code. So right now you can do this with what we call application stacks. So that would be like something like sample stack WordPress. WordPress is basically installing the namespace components of the things needed to consume WordPress into a namespace in your cluster. So once you install this app stack, then you can create something like we have here with this information here. Like it will provision a MySQL instance claim, a Kubernetes application claim. I think it does a Kubernetes cluster. I'm not sure if this does remote provisioning or in the actual cluster itself. But essentially you can abstract things away. But as you'll see here, this requires writing some code that actually watches for those resources and then creates the necessary like produce Kubernetes application, produce MySQL instance. So you actually have to learn how to provision those resources in a repeatable manner. And that's really not a way that most people are going to want to be able to provision sets of resources together. It should be something that's able to be just configured declaratively instead of having to write an entire stack for it. So what Muvafiq is working on, and is this Easy Stacks one-pager, which kind of uses Kustomize, I believe, to be able to define this kind of thing in just YAML. So one thing that might be useful to look at momentarily is a cross-CD repo where we've basically created customized configurations to create all these types of infrastructure for you. But what Muvafiq is doing is saying you can provide this kind of customization and then deploy it with a CRD. And this would mean that instead of creating a WordPress stack, for instance, you would have YAML that defines what you need for maybe all of WordPress, including the classes and that sort of thing. And you'll see things here like Cloud Memory Store instance, cluster class, global address, network, subnetwork, all of these things. And instead of having to write a controller to provision them, you'll just define them as customized manifests. And then we'll have a general purpose controller that basically allows you to apply all of these resources at one time. So it's basically executing Kustomize for you in the cluster, which allows you to much easily create your own stacks for resources. So if you have thoughts on what you want that experience to look like, I would encourage you to jump in on the conversation happening here. Another thing that's top of mind is the consumption of Kubernetes clusters. So if we look back over here, we're having to provision a Kubernetes cluster to be able to deploy a Kubernetes application into it, which means that if we have an existing Kubernetes cluster that wasn't deployed with Crossplane, or we have a like a bare metal cluster that's not supported by a stack, like AWS or GCP or something like that, we can't schedule resources to it, right? So we can't provision resources to remote clusters that were provisioned in a way other than Crossplane. So to do this instead, we are proposing, and I've done some work on this design here, and there's a pretty complete one-pager. We're just ironing out a few more details here about how this could be provisioned, or how this could be implemented, excuse me. And what we're proposing is the creation of a Kubernetes target resource. So if we look back over here, we're scheduling to Kubernetes cluster claims. Now, this is not the best model right now because it's saying that a Kubernetes cluster claim is responsible for a few things. Usage of a resource, provisioning of a resource, and consumption of it. So we're using this cluster claim to essentially create dynamically this Kubernetes cluster. Also get the connection secret information. So that's something that needs to be included here, is the way that the Kubernetes application is able to actually provision onto this cluster is by a similar kind of process where you have, let's call it a Kate's connection. That allows you to connect to that cluster. So when you have this model, it means that you're not able to do this across namespaces either. So let's say that we have another namespace, which we'll put up here. That also wants to provision resources to this same remote cluster. Well, a resource can only be claimed one time, so it would not be able to schedule here with a Kubernetes application can only be scheduled to a Kubernetes cluster claim and its resource, because we can't have another one of these Kubernetes cluster claims that also points to this EKS cluster. So what we're proposing is taking this same model and making some slight modifications. So let's take this and see if we can capture everything here. All right, that actually went smoother than expected. So we missed a few things. All right, so we have this same model, but you can now consume this Kubernetes cluster that's provisioned with Crossplane from another namespace because we have a new Kubernetes target resource. So what the Kubernetes target does is, and we'll create another kind of box for this here. So a Kubernetes target, which is also namespace, is now what a Kubernetes application is scheduled to. And let's see here. So it can be scheduled in the same manner. It's just looking at a different object now. And this is essentially what we call publishing of a Kubernetes cluster. So it's saying a Kubernetes application in this namespace can talk to this Kubernetes cluster. And what a Kubernetes target does is it either references a local connection secret. So if this already existed, then it can reference it directly, and then we can schedule this Kubernetes application using this secret to schedule here. But let's say it didn't already exist because we claimed it in this namespace, and now we want to use it in another namespace. What a Kubernetes target can also do is point to a managed resource. So once again, this Kubernetes application is being scheduled to a Kubernetes cluster, and when this Kubernetes target, is being scheduled to a Kubernetes target, and when this Kubernetes target is pointed to a managed resource, it takes the secret. Sorry, this should be over here. It takes this secret and it will propagate it to the namespace, leading to, oh gosh, hold on one second. Leading to the ability to schedule from this namespace also into the target Kubernetes cluster. So now that this exists, then we could essentially, let's say this had just another namespace in it or something like that. Then in this target cluster, we can also create a namespace. So as a use case for this, you can think about, what if you have a dev cluster here, and you are going to have all kinds of application schedule resources there. It's kind of your Wild West cluster, and you say, if you have something you want to run, you can run it on the dev cluster, and so I'll make this available to your namespace. Then an infrastructure owner can create this Kubernetes target, which makes this available as a scheduling target for resources, so an application or something like that. Another scenario would be if you took this Kubernetes cluster, let's say you didn't dynamically provision it. So this EKS cluster was just created statically, which led to the creation of this. So let's go ahead and, well, actually we'll do a different scenario. So let's say in another namespace, you have this bare metal cluster. So let me create another namespace here. And Marcus, I see your comment there as well. I'll get to that for sure. Talking about scheduling to the control cluster itself. So we have another namespace where we want to be able to provision a Kubernetes application to an existing cluster, one that is not represented in the Crossplane ecosystem. Then you can manually create a Kubernetes connection. Keep doing that. You can manually create this secret in the namespace. Let's say you're an infrastructure owner and you have the kube config information for a cluster. So we'll call this on-prem Kate's con and make it namespaced. So when you create this Kubernetes target with a reference to the secret, that did not work how expected. Then wherever this cluster is running, you can now connect to it. So Marcus says to zoom in, so I'll try and get a little closer here. So let's say we once again have a barrier, and this is representing an on-prem data center here, where you have something like your on-prem Kate's cluster. You can now schedule this Kubernetes application there as well. And you can get into even more complex situations where it's running on an on-prem cluster and it's consuming something like an RDS instance database or something like that. There's really, the sky's the limit for it. One thing that Marcus also mentioned is that you can provision directly into the control cluster, right? So you could have your Kubernetes application running in this cluster. So essentially it would just be creating a deployment or something like that in the local cluster. And so instead of scheduling to a remote cluster, you could also theoretically, it may just be easier, except for that it's less portable, that you could just create the deployment and namespace and service directly in this namespace, and then they would obviously be running in the Crossplane ecosystem as well. But packaging it as a Kubernetes application says I can run it in this cluster, I can run it on an external cloud provider, or I can run it on my on-prem location as well. So that's one of the things we are working on. Like I said, there is a design for this here that has some of the information. I think one of the useful parts, at least it was useful for me when writing it up, were these different scenarios where there's different permission levels. So one of the benefits of adding a new resource type is that you can set RBAC permissions on that. So traditionally, you'd probably only want the infrastructure owner to be able to create a Kubernetes target. And that would essentially isolate the ability to consume a cluster. If any application owner could create this Kubernetes target, then they could always just point it at any cluster that was provisioned in Crossplane and then be able to consume it. So we don't want that. So you'll see here an infrastructure owner provisioning and publishing Kubernetes cluster, an infrastructure owner provisioning and publishing some Kubernetes, but also enabling self-service. So that is the example where you're actually claiming the resource using a class. So let's say an infrastructure owner says for all dev kind of work, you can just create a cluster on AWS as you see fit using this EKS cluster class. When the Kubernetes cluster claim is created and becomes bound, it actually will create a side effect Kubernetes target. So once again, the application owner doesn't have to be able to create a Kubernetes target. They just have to be able to create a Kubernetes claim that references a class to enable that kind of self-service workflow. And then lastly, you'll see kind of this on-prem cluster scenario, which we walked through as well. If you want to get into the technical implementation, that's down here. Another thing that adding this separate kind of publishing resource does is it allows for intelligent scheduling in the future. So that means that if you want to schedule based on geography or something like that, we could add those sorts of fields to the Kubernetes target, and then the Kubernetes application scheduler, which looks for Kubernetes targets in its namespace. So let's say you had something like, 20 Kubernetes targets, or we'll say 3 because that's easier. If you had 3 Kubernetes targets, you could put labels, a label selector on your Kubernetes application that says, find one that's labeled dev. Right now, that kind of scheduling is enabled. You could also, in the future, potentially say, like, find the cheapest one, or find the one that's closest to where this Kubernetes application is going to be, close to users and that sort of thing. So intelligent scheduling is definitely something that's on the roadmap as well. So outside of that, we are continually looking for new things that Crossplane users propose. We are definitely open to any feedback, and we've actually been able to enable some of that. I know that in a recent release, and I think it's listed here, let's see. I know that we introduced kubeconfig actually in the secret. Muvafiq did some work to add that, which allows you to directly create, and let me find the PR for here, which allows you to create or consume these Kubernetes clusters a little bit easier. And let me see if I can find this here. I believe, yeah, so here you see Muvafiq added these raw kubeconfig secrets on each of the stacks, which basically means this Kate's connection secret has a actual kubeconfig field, which has the full configuration for being able to talk to that. That was desired by some folks in the community who are looking to extend Crossplane and be able to connect to these clusters and kind of see what's going on in their remote clusters. I don't know exactly what they were building, but we saw that as a great thing. So we wanted to enable that, and it was strictly additive. So that was a great value. So, if you have things like that you say, I think this could work a little bit better, or my developer experience or user experience would be better with that, we're definitely open to hearing that. One thing we'll definitely be focusing on is easier development. So I think the easy stacks do that, and then you'll also see some things about template stacks, which allow you to more easily create kind of automatic, repeatable deployments of infrastructure and applications without having to write actual Go code. All right, so this has been a bit of a sprawling episode, but I hope that it provided some additional context. Once again, do not take this diagram as law here. It's simply kind of like a walkthrough to kind of illustrate how things work in Crossplane, but it once again would not be enough to actually provision secure connectivity, but it is a nice kind of summary. Maybe I'll make a nicer one for everyone to be able to consume at a later date. But anyway, I really appreciate y'all tuning in. I want to give a quick shout out to everyone who's been in the chat. So I see Jared. So we referenced Jared, who wrote the blog post here and is a founder of Crossplane. Thanks for joining. Javad was on here, implemented cross-resource references. Steven, he works on some UI stuff. I think he might have a PR open here about UI metadata. So that's something that's on our roadmap as well. Basically saying, what do we want to be able to expose if someone wants to build a UI on top of this? It's probably a better way to, UI annotations and that sort of thing. So 0.6 is our next release. Steven's been working on a lot of that sort of stuff, so making these custom resources easy to consume in a user interface. So that would be great. And let's see, Marcus obviously is here. Marcus is a faithful listener and a former host, and he works on a lot of the template stack stuff, so thanks for joining. To anyone else on the call, we appreciate you being here. For anyone watching later on, please feel free to join the community, ask questions, ask me personally about how I could draw such a terrible diagram, and I will try to answer any of them and make it a little more consumable for you. With that, I'll let everyone get back to their Thursdays, and you're a day and a half from the weekend, so hang in there.